So we're going to run it over here and lower, right over here.
Yeah. You can move it back. Jump rope. Okay, so the most important thing is not to let go. Okay. If you see Tom has it wrapped around his hand, okay, they'll ensure security. Okay.
No, just never let go. What we're going to be doing, we're going to be doing all sorts of crazy things. Dancing around, holding the rope, stepping under one another. And if you let go, then we'll lose track of everything. So just hang on as tight as you can.
Whatever you do.
And the color of the rope you have doesn't matter. Where you're standing doesn't really matter.
But right now we have 2 parallel ropes.
Right.
Okay, and what we want to do is we want to go through our little dance, make tangles, and try to assign numbers to the tangles.
Okay.
Okay.
Because right now it's just their images. So you just see 2 ropes. But a way to sort of keep track of what you're doing is if you assign a number to each arrangement of the ropes.
Okay. We're going to call this 0. Okay. You just arbitrarily
Decided that this will be 0. This position.
So, okay, so if we rotated 180 degrees, so if you move around the circle, so keep going, okay, stop. This is also 0. Gotcha. So it doesn't matter which rope is where. This is parallel. Right? Yes. Parallel to the brick wall. Okay.
So we just pretend that both ropes are the same color.
Yes, exactly.
Yeah.
And then you're all the same
person.
Yeah.
And so we are like this.
So, yeah, you can't tell us apart, you can't tell the ropes
4
apart.
makotos and 2 green ropes. But the reason why that they're different colors is because when we start tangling them, it'll be easier to see what's happening with one's yellow and one's green. Okay, are we ready for our first dance step?
Let's do it.
Yes.
Okay. This is called the twist.
All right.
It's not the Beatles kind of twist.
Oh.
Although you can do it while you're doing it if you'd like.
Okay, so the twist is going to take the person in this corner.
So the rear person with respect to the audience.
Okay.
Our huge audience here.
And they're going to go on.
He's going to lift.
A lift.
Rear person lifts. Front person goes under.
And you change places. So you want to stay in this square. Okay.
Gosh.
This
This is one twist. It doesn't look that exciting,
It's an X.
but we have changed it. This clearly isn't 0 anymore.
No.
Yeah. Do we have 2 vertical angles?
2 acute angles and 2 obtuse angles. Well, vertical angle right here.
So we have 2 pairs of vertical angles.
Oh.
Yeah.
Very good.
That's a good observation.
You can come to my class.
So now we've got, that was 1 twist.
Yes.
Go ahead and do another. Let's
Twist again.
So, rear up, front goes under, 2 twists. Suppose all we did was twists. You guys just continued to do the twist move over and over again. What would happen? You're welcome to try that.
We get one in a big. Timber hitch.
A what? Timber hitch. Oh. Well, I don't know. If they continued to twist, would you get a very strong knot?
No, it's kind of a twisted rope. Very strong rope. I think it would bear resemblance to timber hitch.
Perhaps it might. You'll have to draw us a picture of that afterwards. I don't know my knots very well. So, but we kept twisting. We continued.
Hangman's moves.
It would just continue to twist and twist and twist and twist.
Right. Yeah. And pretty soon it'd get hard to hold on to.
Yes, probably. Let's go and do a 3rd twist. Now everybody look at the rope that you are holding.
Helix.
And try to see, where is the helix? What's it doing?
Twisting around himself.
Twisting around itself?
Each other.
Yeah.
In
In
my
a
direction.
direction, yeah.
So we're going to, if you see, okay, your rope is going, we're going over the
Sure. move back.
Okay.
Oh.
Start from your end.
Okay.
So she's listen to Laura describe the way her rope looks.
Okay. Over here, am I doing it that way?
You're doing this way.
It's coming this way, then it's going up and over, so it's like a clock, how a clock spins.
Yes.
Okay.
Yes.
Like a clock, is
That
your
was
going
your right. You
clockwise or
start from your
counterclockwise?
left.
Your green rope. Like if we watch and it goes over.
From here, it looks like the green looks like counterclockwise.
Why do you say that?
Are you looking from starting?
It's going clockwise, yeah.
Clockwise.
What about you, Karen?
Where's question?
Is your rope going counterclockwise or clockwise?
It starts here and goes that way and this way and that way. So
Clockwise. Clockwise.
No,
Clockwise,
sure.
clockwise, clockwise, clockwise. Oh, okay.
How does it all look clockwise? He's facing the opposite direction of me.
That's a good question. What if we switch places? What if we go around? Do you
So I'll hold your rope for you while you're switching, because we can't let go.
If you want to come and take a look.
And you can go and take Tom's spot.
I will take a look. Now what do you think?
Oh, it still looks clockwise.
It still looks clockwise. Okay.
How's that possible?
How many half twists does it look like you see?
Half twist?
Half twists. So full just be a full 360 degrees.
I thought there's two half twists.
This one's a little tricky.
That's enough for each twist, or is it two?
Yeah, pretty sure. So when we twisted the first time,
Can I go back to my spot?
Doesn't matter.
Yeah.
What do you like it there again?
It looks different now.
we'll get you back to where we want to be in a second. Okay, so when we did the first twist, right, we went under and went over. Okay, so that was one twist. Yeah? How many twists do we see here? If we say, okay, under and over, when they cross, that's one.
Two.
Three. Three. Because I can say
Yeah,
one, two, three. Okay. So if we started at 0, what number are we at now?
3. Yeah.
Yeah, we did 3 twists. So each twist adds what to our number? How does it change our number?
Adds one whole number.
It adds a 1.
One whole number.
Very good. Very good. Okay, so we're going to do an illegal move now. Okay, we're just going to do it this once. We're going to do what we call an untwist. Okay? So think about what the twist was. And I want you to untwist.
That's okay.
She can do it.
She can die.
Okay, so we have
Exactly.
1. So now what number do we have?
2.
2. So an untwist would have done what?
To the number.
One.
Yes, yes.
Take away 1. Yeah.
Twist one.
Sure. Let's go back to 0.
Ah, are we at 0 now?
no.
What are we at?
1.
Yes.
Awesome.
Very nice.
So this is back to 0. So now we kind of see how the twists are working.
Right.
The twist adds 1 to our tangle number. Okay.
So if the only move we can do is twist, can we ever get to -5?
No.
Can we get to 3/4?
Well, maybe we can. We just stand right.
A partial twist? What about if, I don't know, I tangled everything up. We just did a bunch of twists. We did a bunch of untwists. We did all sorts of the 2 moves that we know so far. And then I lifted it up and I said the number of the ropes we have now, 17. What would you know about the moves we've done so far? Possibly.
You twisted 17 times and twisted 20 times and then twisted 3 threads.
Yes.
Exactly.
Very good. Any other options?
Lots.
Yeah.
Twisted 10,197 and then untwisted, say,
17 less than that.
Yeah. Okay, so the number of times that we twisted has to be what? At least 17.
Yes, it does have to be at least 17 because we end up with positive 17. How does it have to be related to the number of untwists?
it has to be more than.
How many more?
7.
17 more.
17.
Exactly. Exactly. So we could have done any number of untwists. We could have done a million untwists. As long as we did how many twists? 1,017,000.
Yeah.
Yeah.
Let's do just an untwist. So we're at 0, and let's untwist.
So if we go there, then we twist. We can't untwist.
Not quite. Let's see what happens if we untwist. So the front person lifts. That person goes underneath.
Okay, do it again. Now look at your rope.
Twist it.
What direction is your rope going?
Going that way, right?
Yes.
Counterclockwise.
What about you, Marco?
A clock goes like this.
So it's going.
A clock goes like this.
No, this is clockwise still.
Well, okay, so it's going over and under.
But it's going over in this direction.
No, from you.
From you, we're starting here.
Over.
Under.
So what direction does it rotate in?
Clockwise.
Counterclockwise.
Let's do another untwist. Maybe it's easier to see when we have 3.
We do a few untwists.
Okay. Okay,
Let's
untwist
untwist again.
I'm getting in head.
One more, just for good measure.
Okay.
All right.
All right.
Yeah, now it's a little clearer.
Oh, well, now it looks like it is going clockwise from here. Yeah, counterclockwise.
What direction do you think it's going for everyone else?
Counterclockwise?
Uh-huh.
Is it?
Yes.
Yeah.
Okay. So it's the same frequency. I want to give you another move. Okay, this one's a legal move. Okay, it's called display. So in display, our back side is going to lift up, our front side is going to go down, back, and we show the camera. Look at our tangle! Yay! And then if we had a room full of applauding,
So you're responsible for all the applause.
when we display, we get applause and cheers.
And we'll let Tangles a lot more complicated than this, so you'll need to lift it up. So let's see what's going on.
So can we do anything more than twisted, untwist, or just untwist?
That's a good question. Well, now we know display as well.
It's admittedly kind of getting old.
Ooh.
Okay.
It's up new.
Well, let's go back to 0. Get us back to 0.
What are you doing to get us back to 0?
Twisting.
Twisting, right? Because we're undoing the untwists.
So shouldn't we be at 4 now?
We did 5 actually. We were at,
So 5 now.
what number were we at?
With the untwists.
Five, okay.
No,
After 5 untwists, are we at 5? We started at 0.
-5.
negative.
But you said that it's possible to go to -5.
With just twists.
Oh, we were untwisted.
So now forget about untwist for a second. That one's illegal.
We're not going to do untwist anymore. But we are going to give you something else. We're going to give you a rotate. Okay. So what happened?
No,
We did. We rotated 180 degrees. Now, in our terminology, what we did, that 180 rotation, that's 2 rotates.
So when you rotate, what you're going to do is you're going to move to her space. So you just move over here. Stop! This is our rotate.
So this was just a quarter of a circle. How many degrees did you rotate? 90. This is 1 rotate.
Is this a number that we know? So we started at 0. It's a half. Okay, it could be 0. It could be a half. Okay, so what do we know about twisting?
Twisting adds whole number.
Twisting
Yes.
adds a whole number. So if this were 0 and we twisted, we would get to 1. Let's try that. I want you to twist.
So back person lifts. Dakota, you go underneath.
Oh,
You guys
yes.
said, what number do we have now?
Same.
So whatever number this is, I don't know. Should we call it X, Sarah? This number that we have right now?
Sure.
Do you have a favorite variable?
I know.
Z. All right, let's do it.
0 label 2.
So we've got Z.
Oh, so we didn't start. We started at 0.
We started at 0.
What about 0 label
This is our notation. So we have our starting point. We
Wait.
draw an arrow.
What about 0 label 2?
0
Do
then?
that. Zero and a little two.
Sub 2.
Yeah.
We could.
But do we know that it's a 0?
No, we don't.
We could call that. Yeah, and we can, I mean, that's what's cool about variables. You can arbitrarily assign them.
Well, it's sort of.
All right, let's go ahead and call it that. We'll call it 0 sub 2.
How do we get to 0
Oxygen.
sub 2?
Where's zero?
How do we get to oxygen?
We rotated 90 degrees.
That is what.
We rotated. Okay, so here's our integer. We have our error that shows that we're doing something, and then we'll put a little letter above that says whether or not we rotated it or we twisted.
So T for twist, R for rotate. And now we're at this 0 2. And then what did you do? You guys did a twist, right? So we did one twist, and where did we end up?
Zero, two.
Yeah.
Oxygen and Z
Now,
So if you look at this, what do we know about twisting?
This doesn't really do anything from this position.
Well, but what does it do in general?
It adds 1.
It adds 1. Okay, so here we have a case where we have something, or we have oxygen plus 1 equals oxygen. Do you know a number that can do that? 0. 0 plus 1 is what? 0?
Would be
The
the
absolute
inverse.
value? Inverse one. Yeah. Absolute value?
So the inverse of 1 is
Negative 1.
no, the inverse of 1 is just 1. Well, it depends on whether you're talking about multiplicative inverse or additive inverse.
Correct. In this case, we have the additive inverse.
Okay, so negative 1. And then we
Plus
have 1.
1,
And what do we
plus
get?
Zero.
Is that what we wanted?
No, we need to get back to itself.
Mm-hmm.
okay. Multiplicate. Okay.
So the multiplicative inverse of 1 is also 1.
What's 1 plus 1?
2.
Is that right?
No. Good try.
Divisible inverse?
We're thinking of some, and it's tough. I mean, I'm trying to think of any number where if I added 1 to it, I'd get the same number.
I can't think of
Plus
one.
1 gives you the same thing. No.
What if it's not really a number?
Well, if we thought about imaginary numbers,
Imaginary numbers. Yeah.
like 2i plus 1, and we added 1, then we'd have 2i plus 2. Or 2 times the square root of negative 1 plus 2. Is that the same as this?
No.
So probably not imaginary numbers.
No.
What about? Yeah.
What about infinity?
Infinity?
Infinity.
That's.
Do you know what infinity is?
Sure.
Means an unlimited amount of something.
All right.
So stuff.
Infinite plus infinite, like if there's a bank account sort of thing.
Do you have an infinite bank account?
No,
That would be pretty wonderful. So you have a bank account.
and one of them is infinite, and then there's another bank account that's in like say debt, like $1,000 debt, and they merge
Then what would happen to the infinite bank account?
Infinite minus 1,000 is still infinite.
Exactly.
Very good.
So we have infinite plus 1 is what?
Infinite.
It's still infinite.
So now we stop calling our number oxygen and change it to infinite.
So this figure we have right here,
0, 2.
what do we think we want to call
Infinite.
it? Infinity.
Are there any other numbers that would work?
Sideways 8.
I'll just tell. How about negative infinity? Would that work?
Yeah.
I guess.
If you owe an infinite amount of money and you pay off one,
Still
still owe an infinite. So negative infinity would work too. That's just
Yeah.
the point.
Positive or negative infinity.
Whatever infinity means.
Okay.
But it seems like a pretty good name for what we have here.
You want to do some algebra?
Yeah.
Just do something cool.
Yeah, absolutely. Let's do that.
So here we want to, or okay, let's look at.
So 2 plus 1.
Yeah. So we want to solve this for O2.
Because that's what we're trying to do, is figure out what number that O2 is.
What happens when we?
We already figured out it's infinite.
Well, but what if we had started at 1 and rotated? You want to try that?
Yeah, let's
Sure, let's start at 1.
Let's go back to 0.
So go back to 0.
Okay.
Because we know where we are.
And then to get 1, what do we
How
have
do
to
you
do?
How do you watch?
Do I go up? Yes, you are.
One twist.
We twist,
One.
and we get to one. Okay, here.
Display.
Display. Yay! Roll.
Pay your
One.
clap.
Thank you.
Okay, now let's rotate.
So
Oh, we need to rotate once.
clockwise.
Stop. Are we at infinity?
No.
No.
You're still at one.
Are we still at one?
Are we?
We're at one plus a rotate.
They can
Yeah.
test and see
Yeah.
if we're infinite by twisting.
We could
Okay.
do that. If this were infinity and we did a twist, what would we end up with?
Infinity.
All right, you want to try it?
Okay.
That's a great idea, testing it out. Let's do it.
Twist.
7 now has 0.
One twist.
Ah. So if we're at 0 now, could that have been infinity?
No.
What did it have to be?
-1.
Exactly, because we did a twist and it took us to 0.
So if we do.
So go back, can you remember what -1 looks like? You can always do it in one twist again.
No, you
Don't take that off.
sorry.
This was -1. And we got there by doing a twist and then a rotate.
Okay, so we have two things to look at now. We have this when we start from 0 and we do a rotate and then twist, we end up with that infinity.
Infinity.
We also have if we go 1 and we rotate, we get -1. Okay, so let's look at this one first. How do we solve this for O2? Look at that.
Minus one.
But I thought we already solved it. O2.
If this were, okay, so if we call it x instead of O2, because it might be easier to see, and we have x plus 1 equals x. How would we solve that equation? Algebraically. What can we do?
English or
Subtract
not?
x.
We subtract 1.
Okay, can we just subtract x from left side?
No.
Okay. So what do we have?
Equals 0.
We have 0 plus 1 equals, I'm going to write it like this. Okay.
Oh, this math is going to be so good.
We're almost done. Okay. So
Don't try this in school.
So if we have x minus x, what can we do?
What equals?
Let's factor out the x.
Use the distributive property.
Yeah, so we're going to undistribute this x. What do we get here?
I need to subtract minus x.
What's 1 minus 1?
0.
Oh,
Okay, so x equals 1 divided by 0.
0 can't be the denominator.
Why can't it be?
Because
Because
that
I
would
have
be, yeah.
Would you have
Nice.
noticed?
Undefined. Yeah.
It's undefined.
What if we got really, really, really close to 0? I don't know. I mean, we could do 1 over, what do you say? 1,000?
Yeah, that's still not the same as over 0.
It's not. Let me get a little closer.
What's that?
You can add.
What number is this? This is 1 over 1 million, which equals.
1 million.
1 million.
It's
Okay,
not.
but if we get this, so we can get as close to 0 as we want. We can get closer and closer and closer and closer and closer and closer and closer to 0, right? By making the denominator smaller and smaller and smaller and smaller. What happens to this answer as we make this really, really small? It gets bigger and bigger and bigger and bigger and bigger and bigger and bigger, right?
Infinite capacity.
So it approaches
Bingo.
Yes.
Yeah, so we can say that this is kind of like infinity.
Right.
Yeah.
Like we said earlier.
Okay, which is what we had. We said O2 is infinity. Okay, so hang on to that relationship and let's look over here.
So I'll keep track over on this side. What we
We still need to call it O2 if we already solved it.
No.
We can call it infinity. So we said if we started with infinity and we did a rotate, we got to infinity. Whoop.
No.
Sorry.
Number 0.
Yes. I'm sorry. And then rotate. And we get to infinity. If we did infinity in a twist, that's what I meant, right?
There we go.
That's
it. Okay, and if we have 1 and we rotate, what did we get?
1 we
let's redo it.
So go back to 0, reset,
0.
go to 1, rotate.
And what did we say this was?
1.
Are you sure?
Well, if it's 1 and we
rotate.
twist.
Did we say it was negative 1?
Okay, so
If
for
it's
1,
how can we test if it's -1?
Untwist.
Is it counterclockwise? Do we twist or untwist to solve it?
If it's 1 and we untwist, then we'll get back to 0.
Okay. We would have to twist. to
wait,
solve it.
sorry, say that again. If
Yeah.
it's 1 and we untwist,
Then we'll
get back to 0.
But if we don't get back to 0, then this must be -1.
Okay.
We have to untwist to do it.
But we can't untwist. Untwist is illegal.
Forget about it. Yeah.
You have it, Laura.
You got it.
Say, so what would we, we're going to twist.
We do a twist.
And what did we get to?
0.
So what did it have to
So
be?
we have 1 goes to,
Negative 1. Because untwist is illegal, so
because when we twisted, we added 1. And what do we have to add? What does this have to be if we added 1 and got 0?
-1.
Negative 1.
twisting and rotating equals.
So what we want to focus on is this relationship. What happens when we rotate? 1 goes to -1.
0 goes to infinity.
Or, if you look at it like that, 0 goes to 1.
Should we see what happens to a different number? What's another number we can get with just twisting?
2.
2? 3? Sure, let's do 3. So let's go to 3.
Okay. 1.
1 twist, 2 twists, and 3 twists. So we went to 0, we did, do you guys know what exponents are?
Yes.
So if I said 3 squared, what would that be?
It's 9.
Yeah, 3 squared is 3 times 3 equals 9. So we're just going to expand our notation. 2 twists. Write that as 2 to a square. So we did a 0, and we did how many twists?
2.
We did twist cubed, and that took us to?
3.
Yeah, because a twist adds 1 each time.
Yeah.
So now we're at 3.
Hang on, but if twist equals 1, then wouldn't twist cube be what? Equal twist? Because exponents are for multiplication.
Correct.
Yes.
1 cubed would be 1.
Therefore, that exponent is totally false.
Well, we're using the exponent to talk about. Think of the twist as an operation. Twist doesn't equal another. Think of it as something that you're doing. So we're doing a twist to something that's already been twisted to something that's already been twisted. You can also look at it as we started with a 0. We twisted the 0. Then we went and twisted that. Then we went and twisted that.
Okay? It's not exactly multiplication.
No. Not quite.
Oxidation.
Has to do with functions. Yeah. But that's a very good application. So now we're at 3. Let's do a rotate. Let's see what happens when we rotate 3. Alright, so we rotate. Does this look like something? We don't know what this is.
No. This is bizarre.
What variable have we? We have to use y now. We'll call this y. Now, how can we try to figure out what this is?
Twisting, untwisting, twisting.
Twisting.
We can't untwist.
So I guess we can.
Why can't we do it like untwist this way? Does it always have to go this way?
Yes.
Okay.
We're restricted. The only moves we know are the twist, which is lift, under,
Twist.
and display, and rotate.
Display is my favorite. Okay. So what happens? So we just did 3 twists and then we rotated. And our options are to display, which won't really get us anywhere. It will get us an applause. We could twist again, or we could rotate. What do you guys
What
want?
happens if we rotate?
Yeah.
Yeah, that'd be
We're back at 3. No.
Yeah, exactly. What are we back at?
3.
3. Is it 3 or is it negative 3 now?
Well, let's test it.
No, it's 3. Which way is it going?
You can always test it.
If it's negative 3, what will happen if we
it's still
twist?
3.
anymore, Tangle.
No?
Okay, we can't untwist.
It's not allowed. The ropes will not twist on that side.
Okay.
If you guys really want to twist, what did we just figure out here? We took 3, we rotated, then we rotated again, and we got back to 3. So if you guys really want to be the ones to move, what can we do twice? How many rotates do we need to do? 2. Yeah, so let's do it. Then you guys can be the one to
How
move.
can I get this 4 back to 3?
So we did 1 rotate, 2 rotate, and we're still at 4. 4, right, so you guys did a twist. So now we're at 4. So if we do, what do you want to do? You want to keep twisting? Will that eventually get us back to 0?
No. Wait, how do we get to 4?
They twisted.
Yeah, it didn't have a twist. We've lost control.
I think we've got too far away from our goal. Our goal is to figure out what rotate.
What rotate does to the
So I want to click the imaginary reset button. Okay. So I want 2 of you to let go of your ropes.
Just, we can just do.
Fix this.
Ta-da!
Just rotate once and then.
Let go of your rope. Okay, so what I want to do.
What are we supposed to do?
Okay, so we got a little crazy, right?
We did. There's a lot of twisting going
Okay,
on.
but now we're back to 0. Okay, so we're at 0. I want you to twist twice.
3 is just too complicated, remember.
Twist. It's too advanced for us, so let's twist twice. Twist twice.
1.
1,
2.
What number are we at?
2.
2. Okay,
Alright.
now let's rotate.
Rotate once.
Once. Just 1 rotate.
1 rotate. And
What
now we
number?
have the monster.
What number are we at?
Not
2
sure.
rotate.
Because
2 plus rotate.
2
Yes.
plus rotate, so we're going to call that
A
Y.
rotate of 2 if you want to do it.
There we go.
Functional notation.
Yes. Functions.
Okay. So,
we have to figure out what number this is. Now, what do we know? What if we rotated again?
don't do it.
Back at 2.
We're going to be back at 2. Okay, so what would happen if we twisted?
but
Twist.
what if we can't
We
we
would
can't
be-
untwist?
That's sort of nice.
That is sort of nice.
Can we rotate and twist and then? I don't know. What are we at? Is this
What are we at?
This is
What
just
is
the
it?
exact same as
I'll call this
Y.
N.
No, I don't. I want to know
It
what
just
this is.
is.
It looks like Y.
It looks like Y.
But we're not. I knew we were trying to
It
figure out
looks like
two.
Y, but what?
What?
I didn't really pay too much attention to Y.
It's a
It's just think it looks like Y.
How many of them?
Is it back to 2?
But
It
it's
looks,
like
it's back to
it
2.
looks like the mirror image of 2.
but
It looks like that'd be opposite of 2.
but it can't be
Because you can't untwist. So
but it can't be
So it can't be the opposite of 2, like -2. You're right, because then you'd be able to twist and take it back to 0.
and it can't
I don't know. I think
Not
twist
unless
is.
we
it
rotate.
can't be in it can't be in and even though we twisted and it looks the same, it can't be infinite because that's what we got ourselves parallel to that wall.
Right. This is definitely not infinite. Good observation. And you said, what if we rotated and then twisted? Because this isn't quite -2.
But it's two.
So we did 1 rotate. And then what'd you say, Laura? 1 twist.
Twist. Twist twice.
1 twist. 2 twists.
Rotate plus 2 twists solves the 2. Yes.
And we did 2 squared.
So it's somehow
0.
No.
it somehow got to negative.
Yes.
Yes.
So y equals.
So what's this number? I just called. So after we rotated. Okay, so after we rotated, before we did the 2 twists, we got to W.
Exactly. Exactly.
Well, it's negative.
Because 2 twists resolved it to 0.
No, first we rotate and then 2 twists.
Ah, but just from the W to the 0. You know, the W has to be at -2.
Yeah.
What this thing is, I have no idea.
So what is Y?
I don't know. We need to know what Y is. We need to know what
By
circle
rotating,
is.
you make it negative.
So that is Y.
This is a little bit like 0.
Yeah.
Yeah, so it's supposed to be S and B.
started using P and then we got rid of it for oxygen. C then.
So now we're at Z again. What was line Z equals?
Now, this is how the work gets pulled out of somebody's hand.
Let's look over again at what we do
Over here.
over here.
0 plus 1 equals infinite plus this equals infinite. And 1 plus 2 equals 1.
We said that this looks like the opposite of this, didn't we?
Yeah, and then I flipped it.
Yeah.
Here, we'll try again. Let's look carefully at what we get. So, start at 0. Just a twist.
So untwist.
We're trying to figure out what y is, right?
Yeah.
So let's get a look at y again. So we know how to get there. 1.
2.
We're now at 2.
Okay, so we rotated.
We rotate. And now this is y.
Okay, so take a close look.
Okay.
See, can you describe what's put in this up here?
The green
From everybody's point of view.
Well, the green row goes underneath the yellow row
It
and
comes up to
back
me.
to me and over to you.
Okay. So now do a twist.
These two sides are on top and
Right.
underneath.
Do a twist now.
There's
Now what does it look like?
Now it looks
See,
like
they're underneath and they're on top.
opposite.
It's like a
Yes.
reflection.
So Z equals y,
So a twist to y took us to the opposite of y.
negative
What
y,
does twist do?
add 1.
So
So y must be negative y minus 1. Or something.
Can you solve this?
Y is negative y plus negative 1.
Well, what can we do? We can add y.
Both sides.
Okay. When you go back to that equation over there.
Well, look at it. So negative y plus y is what?
It's now 2y plus 1 equals 0.
What is y equal?
Y equals 1. Negative 1.
Okay, so look at this relationship. We had 2, we rotated, and then we got negative 1.
That can go in our list of things we're going to rotate. Is to negative. So look, now we've got, let's ignore my infinity twist infinity. It is something we know, but it doesn't really have to do with rotational operation. We have 0 when we rotate goes to infinity.
This is the denominator. Yes.
Exactly. You want to try to test that? I think we tested that.
The negative is
So can you write down the equation and tell me what rotate is?
Here, I'll take your row.
If we're starting at some number x, and then we rotate, what's the difference?
So
Here, we can erase this mess.
rotate it, and we get x rotate
Uh-huh.
equals negative x.
That's a theory.
That's our theory.
What's
Okay,
the theory?
so we have our theory. Our theory is that's our equation for what rotate.
And what did you say? Can you write me the equation for what twist does? I'll hold on to your rope. So if we started with x, and we apply a twist,
Twisted x.
what do we get? All right. Very good. You want your rope back? Will you let go?
Unless you told me to.
So this is our theory. Now, we can't say that it's for sure yet. We have to test it.
Okay.
But we can try it out,
We
right?
can try it out.
So,
I'm going to erase
should
everything.
we reset?
Yeah.
Yeah, let's reset.
So
Back to 0.
Okay. So what if we go back to our 3 twists?
Yeah, we couldn't solve that one before.
But
Right.
I think we can now.
Nah. We're too stupid.
We can do it.
Nah, totally.
You're sure? Okay.
3 twists.
3 twists.
A 1. A 2.
2.
A 3.
That takes us
What are
to
we at now?
3.
Okay.
if we rotate, according to our theory, what number are we at right now?
-1/3.
-1/3. Great. Now our goal, we want to get back to 0.
Yes.
Using just the 2 moves we have. We have to twist and we have to rotate.
That's it.
And if everything goes according to plan, and it does what we think it's going to do, we should be able to do that.
That's gonna be a 3 move.
Oh, display, you're right.
Yeah,
The
let's
display.
try displaying 5 times and see if that fixes it.
Okay. Well,
What do you want to do? Yeah.
Let's see.
You have 2 choices.
We either rotate or twist.
Rotate.
What happens if we rotate? We rotate twice in a row.
Anything, just flips it.
we would get back to
3.
3.
3.
Yeah.
Which doesn't help us at all.
Okay,
No.
then we want to twist them.
Yeah, it's the only other choice.
And just.
Now we're.
Oh, goodness.
Now we're in some ugly place.
But where is that? What's the ugly place's name?
Numerically. Remember, what does twist
So
do?
twist x plus 1, so negative 1/3 plus 1 is
Negative.
No.
1/3 plus. We'll change. Yeah. We make a common denominator.
It's good to me.
Get that?
So 2/3.
We're at 2/3.
But that doesn't move.
This is 2/3.
Now
Obviously.
we need to take away.
So now what do we want to do?
We need to get rid of 2 of those thirds.
Can we
rotate again? Rotate again.
I like that idea.
But now we have
Where are we after we rotated?
-3/2.
Yeah.
Okay, do we want to rotate more?
Probably not. 'Cause that's
Okay. Exactly. We never want to rotate.
Okay, so we want to
twist.
okay, twist.
Oh, that's looking good.
Where are we now? Where are we now?
-1.5.
Exactly.
Okay, what do we want to do now?
-1.5. Rotate.
Rotate.
sure?
We can.
We can't.
We can twist.
Let's see what happens. Let's rotate.
If we twist, then we'll be at, yeah, then we're gonna go back positive 1.5. Wouldn't we go back? We're at negative 1.5 now.
Oh.
So right, if we twist, we'll be at positive 1.5.
Okay.
No. Oh, if we
Yeah,
twist,
if we
we'll be
twist,
fine.
yes.
I'm sorry.
And if we rotate, we'll be at
Rotate will be at 2.
2. Okay, can we get back to 0 from 2 using twist and untwist?
No plunges. Just rotate and
Rotate.
There you go. Yes, we can, because we got from 3 to 2, so we just do it again and now get rid of 1 more, right?
Yeah.
We could. Let's do it. Let's see what happens if we
We
rotate.
just have to
Oh, we're
repeat
rotating?
our- we just have to repeat our formula.
Yeah.
We got to 2.
And then we twist, and then we
Now what do you want to do?
twist again.
If you twist to get to 3, and that's no progress.
Uh-oh.
We're
We're back at the beginning.
Every time we
Okay.
So we're at 3. We're back to where we started. Okay, well, let's try again. Let's rotate.
When you were at that positive number 2, and you guys decided, hey, let's twist again, what's the only thing we can do from 2 if we twist? Can we get closer to 0?
No, you should have
We keep getting farther and farther and farther away.
rotated twice.
Well, if we rotate again, then what do we get back to?
-2.
2 and rotating, you get to negative 1/2. Okay, which is where we were. So if rotating didn't work, what did we actually want to do?
Twist.
Twist.
but we're stuck at 3.
Yeah,
So
so we're
we
gonna
gotta
go back
go
to the beginning and do everything all over again.
Okay, so we were at 3, we wanted to rotate.
Now,
Twist.
we are at negative 1/3, twist, we're at
Twist,
2/3.
rotate,
Rotate it. We're -3/2.
twist,
We're -1/2. Now let's not make that mistake again.
Okay, let's not rotate. So what are you going to do?
Twist. And what do we get?
One half.
1/2, because we added 1.
Now what do we want to do? Do we want to twist?
We could rotate.
We're adding a positive number. If we twist,
We'll get
Yeah,
that.
we're just going to get more and more positive.
Yeah.
Yeah.
We need to rotate.
Because anytime you're a positive number, twisting is going to move you in the wrong direction.
Where are we?
-2.
-2.
That sounds very promising.
What will we do now?
There. Twist.
Twist.
Then we'll be at 1.
Twist will be at what?
1.
Not
-1.
-1. So then what do we do?
You gotta rotate again.
Really? For -1, it's the easiest thing to do.
Twist. Right, twist. Sorry.
Zero.
Display.
Sorry.
We need
Display.
Okay, it's not letting me exactly like this guy before. It's incredibly long.
Oh,
But
it's
no.
longer than this.
But we did show that we were right. We did show that we were right. That rotating.
Our formula is correct.
Yes.
So should we just write that formula down on our list of rotating things?
What do you mean?
On list of things that we learned about rotation.
Well, this covers everything we learned about rotations, doesn't it?
Rotations.
Because let's think about what did we know? We had 0 and we rotated. And according to our formula, this gives us what? -1 over 0. And what if we say -1 over 0 approaches?
Negative. So
So
this is awesome. Okay, let's make a tangle. Let's make a really, really hard tangle. Okay, I'm gonna start us off.
how about we just have one of us hold it, just throw it all together.
But then we're using illegal moves.
That's not on the list. You can't just go throw up.
You're right.
Okay, I want you guys to twist 5 times.
Whoa.
Okay, 0, 1,
Here's a 1.
2,
2, 3,
4,
4,
5.
5. Okay, now what should we do?
But what is this? This brings us to 5, right? We did t to the 5th,
Oh yeah, sorry.
and then brought us to 5.
We could just split.
You got sure. And what do we still have? 5.
Yeah, we can write a formula here for display. X display goes to
That's fine, yes.
Yeah.
Okay, so what else should we do?
Sure.
Or we could just twist more and rotate. Twist.
What do we get if we rotated 5?
Well, -1/5.
Okay.
Now what do you want to do?
Even an
I
hour
want
and
to
a half.
worry about that myself.
Okay, so we're -1/5. What are you going to do? Rotate or twist?
We could twist.
Let's twist.
How many twists?
Yeah. Should you ever do 2 rotates in a row?
No.
Because that just does it. So you never want to do more than 1 rotate, right? I mean,
Except in our one formula for getting from 3 to 0.
not in a row though.
That was an accident.
And we got in the wrong place. Remember, it got worse. Okay, we did the rotate. We already did.
Okay, so we want to twist. How many times do we want to twist?
We could always twist maybe 3 times.
Sure.
3?
3
Let's
times.
do it and see what happens.
1,
Okay.
2.
2. Oh, this is looking
3.
messy.
Okay, where are we now?
We should have 3 and -1/5.
It's going to be
No, it's -2.
2 and 4/5.
Sure.
What's the common denominator? How do you put it?
You're right. 2, this is the mixed number. What if we did it as an improper fraction?
Okay, so I'm going to leave it as the improper fraction because it'll be easier.
To then invert, which we're going to have to do if we rotate.
Okay.
It's a lot different for a 1/2
Yeah.
It does.
So tangle that. Okay, first of all,
What do you want to do?
keep going.
You want to twist again? You want to rotate?
Okay,
Let's rotate.
Yes.
Just rotate. See what happens.
Then you guys will get to do some moving around.
what do you get? When you rotate 14 pins.
-5/14.
Now you see why we didn't like the improper fraction. Because you immediately have to convert it to 14 fifths.
Right, just to change it.
Okay. You want to twist? How many times?
2.
One,
Two.
yeah.
Let's do 2.
Did you say 20?
1,
What do we have?
Wow. So we have negative 5/14. Every time we twist, we add 1, so we added 2.
So that's 28. 28 minus 5 is 23/14. There we go.
Very good.
14s.
This is what 23/14 look like.
obviously.
If you ever wanted to know.
Didn't know that.
No,
Do we want to make it even messier? Or do you feel pretty?
we can make it messier than this one.
But let's do this later.
Okay, let's start with this then.
This one, if this one untangles, that'd be really cool, right?
That would be pretty cool.
Yes.
I don't know if we can do that messier.
Okay. So this is where we're going. Okay.
This is where we are. Let's display so our audience can see what crazy.
How are we gonna do
Are we gonna undo
this?
We've only got 2 choices. We can just twist and rotate. So no letting go and mixing things around.
Because obviously display only gets us half.
Gets us nowhere to display.
It's Jared.
So
That's
we
true. Just value.
we just twisted.
We need a smaller possible positive number, right?
Yeah.
So,
Can we get the smaller positive?
If we twist, are we gonna get smaller possible number?
No.
Okay, so we need to
yeah,
go.
positive.
Nice. Good thinking, Laura.
And what do we have?
Negative 14/25.
Mm-hmm.
Okay, what do you want?
Twisting will
So now, yeah, exactly. Now we are less than
What?
0.
twist.
Okay, we're twisting. What do we have now?
So,
23 minus 14 is 9.
Uh-huh.
Yeah,
9 23rds.
which is much better.
Do we want to twist again?
no. We have to rotate.
What happens if we twist?
Let's rotate.
If
We get more positive, right?
Yeah, so we have a positive number right now.
So rotate.
Yeah, let's rotate. Okay.
Where are we at?
Negative 23. Now we're at here.
Okay, now what do we want to do?
Twist probably.
Twist
So if I
twice.
twist, we'll
Twist
get-
twice.
Twist twice, yeah, because 9 and 18. No,
Twist twice, what does that take us to?
Negative
Still
number.
18 number.
It's still a negative number.
Yeah.
Okay, so what if
It's
we?
different.
So 5, negative 5 nines, right?
Right.
Yeah.
No, wait, if we twist twice, we'll only to get a positive number because we forgot.
Yes, it's 5 nines.
Oh, no, because remember we wanted negative 23 nines, and we're gonna add 2. So what's 2 in nines?
18, so that, oh, so that's
Still
still
negative.
Yes, we're still negative.
Okay, so what
So,
do
well,
we
let's
want
do
to
our 2 twists and we get negative 5 nines. We don't need to subtract, right?
Oh yeah.
1,
And
2.
Hey, that's.
Doesn't that look a little less complicated?
Yeah, yeah.
Okay, so now what do we want to do?
So now we're still negative.
Yeah, rotate, it would be a positive 9/5,
But if.
Okay, if we go to positive 9/5,
which is bigger. That's not going to help us.
It's not gonna help us, why? Because
twist. I'm saying we need to twist one more
Yeah.
time.
Okay.
Twist again.
Okay, so now we're at a bigger number.
so
This
what do we
looks,
got
this
now?
doesn't.
Negative 5 nines, and we twisted 1.
Okay. Twist is, let's just.
Yeah.
Add 1.
Right, add 1.
So that's,
Okay, so
14
4
nines.
nines. Right? Positive
Yeah.
4 nines.
Okay, now what?
Now we're like,
What do we have now?
negative 9/4.
Uh-huh.
What do you want to do?
Twist that. So,
Twist?
Right, I mean, we never want to rotate twice in a row.
Twist twice. Twist twice?
3 times.
3 times.
Because we have to get it to a positive. Yeah.
Okay.
Ah.
So
Four,
what's
8, 12.
oh yes.
So,
Right, it's
One
12.
twist.
One would be negative.
2.
2 twists.
3 twists. So what number do we have?
Okay. 12, 3 fourths.
Yeah, keep moving out of the way. What now?
Rotate, rotate.
Yeah. And this gives us?
Negative 14.
So we want to,
Rotate.
we rotate twice this time.
Sorry.
Yeah.
Twist.
2.
2. Yeah.
1. positive 2/3.
Hey, that looks kind of familiar.
Yes,
Yeah, we
we
did
like
this
this. This is better.
Okay. So now let's do.
Yeah.
Hey, it is a
And what do we get?
Oh,
No,
Negative
half.
three.
So now we only need to twist once.
No,
Are you sure?
Twice. Four.
Twice.
We're at 1.5.
Yeah.
That's okay. That's okay.
Hey, look at
Oh,
that.
this is looking really
One
good.
more twist.
One more twist.
1.5. We like 1.5. Have to easy.
Good.
We rotate.
What do we get?
We are
Negative 1.
-2.
Oh.
Now what do we do?
Just 2 twists.
Exactly. So negative integers are nice.
Very good.
Display, definitely display.
We untwisted it.
Awesome, team. Good job. Good job.
Okay. Okay, so now we get to do something that's so cool.
It's pretty sweet. Let me check the time.
Okay.
Oh, you're out.
Wait a minute. It's 1:30. How long is it go to 2?
Do 2.
We get till 2. Oh, we get to do lots more things. All right.
They should teach this in school or something.
That's what we think.
Okay. We want another Tangles.
Yeah, I want something hideous.
Hideous, yes, terrible.
Yeah, this is disgusting. But keep track of what you do.
Let's use bigger numbers this time when we do it.
Yeah,
All right,
well,
let's
let's start off with 4. We did 3 and 5. We can do more stuff. Let's start
Yeah.
with 4 twists.
All right, 4 twists. Here we go. 4 twists.
4 twists.
Just
Everyone.
1, 2,
2.
3.
4.
Okay.
Okay, now what do you want to do?
I say
I say we do 2.
rotate.
Okay, that's 1.
And where are we at now?
Negative 1.
Uh-huh.
What shall we do?
Twist lock.
How many?
That's
I like twists.
3.
Sure.
1, 2, 3.
What now?
ugly.
Where are we?
Oh, let's see. 11 points.
Excellent. Let's make it worse.
Rotate.
Rotate.
Rotating is looking at worse. It's still the same thing.
That gave us negative 4
11.
11s.
Now,
Now what should we do?
20 twists.
no.
That's I think we'll throw it on our backs. 5 twists.
There's nothing wrong with 20. It's just we want to be out of here within the lifetime. of
Right.
You want to twist 5 times?
Sure, 5.
5 is pretty ambitious. Let's go with 5.
1,
2,
2,
3, 4,
4,
5. 5.
That's nice.
What do we get?
That's a pretty ugly looking tangle. Yes, it is.
Where are we at?
Okay, 51 ones.
All right.
Rotate.
11, 51.
Negative 11. 51.
Shall we twist?
A couple twists
Are
and
we
call it.
done, or-
No, let's do a
Got some
couple
more?
more.
Okay.
One more twist.
You guys are good.
What would it be 51st?
There's a 1.
Oh, we have
Do
2.
2 twists.
2 twists.
We want you to practice your arithmetic.
Darn you people.
That's an 11.
Okay, 11. Okay. So 91 minus 10 first, yeah. That's looking ugly.
That is beautiful.
I think this is going to take a while.
It's ugly.
You think it's done? Let's just play. So we see how successful it is.
Okay,
Okay?
so now we wanna do something
Do
awesome.
something amazing.
Uh-oh.
I bet that if you can untwist without even looking at it,
We're gonna hide the entire knot in the bag.
have the evidence.
Yes, it should be good.
Well, we've got our theory and we proved our theory right, so it should work.
Yeah.
Okay?
Okay.
We're doing it all.
But it's maybe.
Erase our theory.
You gotta work.
But it looks like we erased our theory.
No, it's still there.
Get the whole knot in.
Over here, here, I'll box it in.
Hold on.
Wait, maybe
do whatever you want, and just really make it tight. Okay, and then tie another knot to make sure it doesn't get away.
Okay, there we go. So we now have trapped within the bag
Or not.
a 91/51st.
Hang on, how do we figure out when we're back at 0 if it's inside the bag?
Well,
It equals 0.
Yeah.
And if it equals 0, it's gotta look like 0.
Yeah.
If we do our math right.
okay. Whoever. You got it?
Sure.
So,
I'm not up.
I see.
Okay, we need to get it negative, so we need to rotate, right?
Right.
3.
And then we twist one.
What do we have now?
Negative 5.09.
And then we just twist once.
Twist twice.
Twice. But that's a 91 underneath the 51. 91
I
is
just,
one.
if we do one,
half.
it won't get us to a positive number, we'll still get a negative number, right?
I
If one is bigger than
Oh.
I think we're cool.
I think Dakota knows what he's talking
Yeah,
about.
I think it should still be 1 again. It should be.
What's 50, negative 51 plus 91?
40.
So we do get
So do
positive.
one twist.
Yeah.
Okay, twist it up.
Is this looking any better?
Oh, yeah.
I mean,
This is the point where you really don't want to let go, so.
Yes.
I would wrap it once around like this. No.
Not yet.
Okay.
Oh, wrap it.
We're rotating? Okay.
I mean, looking through the bag, it still just looks like a ball like blue yellow.
So you just gotta believe.
That's not a pretty race.
Okay, so we rotated. What do we have now?
Negative 91 points. Yeah, this time we're going to have to do 2 twists, right?
How many twists?
How many twists?
3.
Yeah.
Because you want to.
Yeah.
You wanna get
Get
positive.
beyond 91.
Yeah.
So 3 twists. Sorry, no relaxing. 1,
2. One more. 3.
Okay.
What do we get?
That's the back. 30 to 59. So 29?
Yeah.
Yeah.
So we're getting closer to 0.
Yeah.
It's
29/40 is better than.
And according to
One
our
rotate.
calculator,
You just did a rotate.
40 and 21.
So what do we have?
Negative 40, 29.
So, two rotates?
No.
I mean, 2 twists.
2 twists. 2 twists.
Yeah.
Yes.
Yeah, we've got to do enough twists to make the 40 positive, right?
Yeah.
One of them won't do it, but one more might.
Whoa. Whoa.
So we're now at
After those 2 twists. So we have 58 minus 40. Gives us
18. Yes. 18 minus
18 29.
Now what?
I like numbers with zeros.
now rotate.
And we're at?
Negative 29, 18.
Uh-huh.
So, 2
How many
twists.
twists?
2. Yeah.
2 twists.
Let's do.
1, 2.
What do we get?
Let's see. 84. So that's 7, 18, 36.
Mm-hmm.
36.
Yeah, 36 minus 29. All right.
There you go. 36.
Yeah, it's right. It's 18, so.
I thought it was 18, but I multiplied wrong.
Rotate.
Rotate.
Because I was multiplying
Now what do we-
8 by 18.
Negative 18 sevenths.
Yes. How many twists are we going to do?
3.
Yeah. Uno.
Dos. I'm running out of rope.
Great.
2.
And that brings us to?
I don't think the bag thing is working. It's supposed to work back.
Yeah, that's okay. We'll cut the bag off. 3 sevenths. Rotate. Negative 7/3.
That means 4 times.
3 times. 3 twos. 3. 3.
3 twists.
Yeah.
Okay.
1,
1, we're getting close. Now what do you want to do?
2.
2 what?
Twist. 1, 2.
So in here,
What do we get?
you can't see it.
Okay. Now.
Rotate.
Uh-huh.
Now we're at
-2.
-2.
2
Now,
twists.
two twists.
But I
1,
served the dad with gold.
2. And there,
Okay.
obviously 0.
Display.
Okay, we're done. Everybody go home.
Don't let go.
Don't let go.
Alright.
That's not 0.
It is?
Are you kidding? It looks
Oh,
exactly
it's
like
zero.
0 to me.
Every time I picture a 0, that's exactly what I think of.
Gotta be violent.
It's better to use your teeth. They want that.
Okay.
Shake it out.
Wait.
Don't pull.
Oh. Because I thought.
Oh. Well, wait on that.
Just like loosen it up.
I don't think
Get a little closer. Give a little slack.
I don't think we got 0.
I did. I think we did all our
Math,
math right. Oh.
Oh. It didn't look like 0 inside. It's just that it looked like 0.
It didn't. It would have
But
what?
you,
How
what do
do
you
you
do
math?
this? You never let go of your rope.
Alright, good job, team.
Yeah. Do you think we could take any number? I mean, 9151 is pretty ugly.
Yeah.
Yes.
It's
So if we could do that, could we do 123rds?
Yeah.
You don't have to. Yeah. Do you think we could take any number and just grind it down to 0 with enough twists and turns?
Yes. They should teach us that in school.
Look at what's happening here.
Yeah, why is that true? Or how can you
Because that's
show
what we're
us?
thinking. We're feeling like that's correct.
But it's
Why is it
hard to
working?
see.
Why is it working?
Well, let's see. If we can find a number to assign to R, T, and D, because we're paying that
Only one is negative and positive, right?
well, maybe not D.
I would look at it on like a number line. Okay. So here, if we have 0,
Get what we said with this one.
Yes.
and we start at some number. Start. Okay. We started at a positive number. Okay, so 9.
That's what we've decided to start.
51.
We could have started somewhere else.
Yeah, we can start at a negative number. But so what happens on our first move? Okay. Yeah, we rotate, which takes us over here.
Make it a negative circle.
And then what happens? How?
Twist it. You keep adding 1.
So you add 1.
Continually add 1.
Yeah.
Continually add more E.
Okay.
And we're right there.
So how do we get past 0? How do we get to that positive number?
Add one more. Add more.
You add 1 more. Okay. Could you ever end up at 0? Just
No.
by,
No.
I mean,
If we're adding 1 every time,
Yeah.
is there a number we could be at here where if we added 1, we'd end up at 0?
Yeah.
negative.
Yeah. Yeah.
Yes.
Okay. But if it's any other number,
If it's a fraction. -1 is a fraction, I guess, if it has a denominator of 1. But if it has a denominator of anything else,
okay. And then you go past 0, right?
And then
Uh-huh. Why did I draw it like that?
because that's exactly how it is. Sort of. So.
look at the denominators.
The negatives are always.
We started with 9151s.
Negatives are always whole.
They're definitely not whole numbers.
No.
But look at what's happening to the denominators. First we got Now move from, well, the numerators are doing crazy things. 91, negative 51, 40, 91, 29, negative 40, 18. They're jumping all over the place. So do you see any pattern with the denominators?
They're getting smaller than we are.
Yeah, after we have this initial jump where we had to flip it because we had an improper fraction.
Yes.
So of course the denominator on the next one is going to be larger because we did that rotate. It gets smaller and smaller. So eventually, what's the smallest whole number we can have down there in the denominator? And if we have a negative number with a denominator of 1, like negative 7, negative 3, that's what all we need to do to get it to 0. Just twists, because a twist adds 1 each time. So if we can get to a negative whole number, we're golden.
So t equals plus 1 and r equals times negative 1 plus what does r equal?
R takes your number, it puts it in the denominator, it's 1 in the numerator, and it takes the opposite. So whatever number we have here, if it's 5, we rotate it, we get negative 1 over 5. If it was negative 3, we get 1 over the opposite of negative 3, which is just 3. So we get 1 over.
Is there even a standard operation for that, or is that like just the only thing that does it?
It's the opposite multiplicative inverse.
What operation does that?
That's the operation.
Yeah.
That's it?
So we think that we can take any number and grind it down to 0.
Yes.
Do you think we can get to any number? Because we just theoretically started at, what did I say, 105 over 17. Could I start from 0? If we actually had those rows, if we take those rows and get to any fraction we wanted?
Probably not.
Yeah. And then?
No.
Uh-huh. Now what happens if we reverse all these arrows?
Well, we can't this necessarily.
We're going to start at 0.
And we'll tangle twice. Or twist
And
twice.
we'll twist twice. See what it gets us. What did it give
What do
us?
we have now?
2.
Okay, which is
It's
the
the
opposite.
opposite of what we had.
Okay.
Let's now do the opposite here. We're going to rotate.
So theoretically,
Now we're at,
Negative.
which is also,
the opposite. So
Yeah.
theoretically, we'll probably get to -2.
now we'll twist.
Twist once. Hey.
Or,
Twist number.
Yeah, it's tangle.
and then we'll rotate.
Yeah.
And what does that bring us to? So if we reverse the order of the steps we took to grind that 2 to 0, we end up to the opposite of 2. Let's see if it works with any.
Well, you check a whole bunch, right? At every step.
At every
you've got
step,
the
that's
opposite. You've actually run 4 experiments here, and every one is giving you the negative of the other.
So if we wanted to get to 173 eighths,
We want to know what steps we need to take to get to 170 degrees from 0. And we just figured out something here.
We could just figure out getting to 8 over 173 and reverse the steps. Just have to-
That is true.
so we reverse the steps. Okay, but would we want to get to 8 over 173?
Negative 173.
And then do a rotate. Yeah, that's one.
So if
Yes.
we had negative 173 eighths,
We don't have enough.
and we took that and we got negative 173 eighths and took that all the way down to 0. What would that tell us? So you have lots of steps, 0. So we start at And knowing what we know from these experiments, how would we get to 173 positive 173
Start from 0 and see all the steps in reverse.
Exactly.
So we would just come back, but because we're going the opposite direction, we would get the opposite number.
And since you guys told us that you can grind any number down to 0, and all we do to get the opposite of any number is those steps in reverse, then we should be able to get any number from 0.
Yeah.
Well, we don't know how to get to -173/8.
Well, we do, because we can grind down what number to 0. And then do the reverse. If we want to learn how to build -173/8, what number do we need to figure out how to get it down to 0?
173/8, but we don't know that either.
But we can figure that one out just with our numbers.
Yeah, we'll have to roll.
And then we can take the ropes and we can build them. You don't believe me?
Well, yeah, why don't we try an easy one?
Let's try it,
Let's
yeah.
try to get something easy like -3, -3,
Sounds
which is not obvious how to get to.
Yeah, so -3, we can't just,
We can't do untwists.
just untwist it right there.
So let's figure out how to do, if we want to eventually get -3, what number do we want to figure out how to grind down to 0?
3.
All right. So what should we do?
Twist.
That takes.
No,
Well,
we
we have to get to 3.
all.
We have, let's get to 3.
We want to get to 3.
If we're not going
We want to get to 0 from 3, because we eventually want -3.
So we can't do this with the ropes, we just,
Right.
because we don't have a 3.
Excuse me.
First thing we rotate.
Yeah,
there's
if we're not
a
going
negative and negative.
if we're not going to be using the ropes, can we sit down?
Sure.
They're tired.
Okay.
You didn't know you had to stretch for math class, did you? So rotate, that's what you said, right?
Negative 1/2. No, negative 1/3. Negative 1/3.
We should just look at you.
Are you sure that's the number we're gonna go with? Okay, and then
What should we do now?
We're going to twist.
Uh-huh. Then what?
2 twists.
2 twists.
So 4, so 1/2. Rotate.
So that's 2 twists.
All right. So now we ground down 3 to 0. We should, to get -3, be able to just reverse, right?
Yeah, right.
So now we need ropes.
Yeah, now let's try it.
Here. Oh, here.
Got 5 people and 4 ends.
Starting at 0.
That's it. Oh, watch.
What's the first thing we want to do?
Twist right there.
Twist twice.
1,
What does this take us to?
-2.
2. We just twisted twice. Yeah, that means 2.
2.
Yeah. Now we want to rotate. And take ourselves to. So far we're looking good. Now this was a double twist. So,
2 twists.
2 twists.
2 twists.
1, 2,
What are we at?
Positive 3 halves.
Yeah, 2 to them.
2 twists. Yes, 3 halves.
Yeah,
Okay. Do a rotate.
Negative 1/3 or negative 3 halves.
Negative 2/3.
-2/3, yeah. Then a twist. Which takes us to,
1/3.
and then we started off with our rotate, so rotate.
And this should be
This should
-3.
be -3.
There's a real easy way to test -3, and that's
Twist 3 times.
twist 3 times and see if it zeroes out. 1, 2, 3, bingo.
Hey!
So,
So can you get from anything to anything?
I want to get from 7/11 to negative 2/3.
Yeah, you could do it, just don't go all the way back down to zero.
Yeah.
You probably wouldn't have to go to zero,
No, you
what would be a way to get there for sure?
Math?
Grind it to zero, and then, because we could get from anything to zero, and zero to anything. So that means you can get from anything to anything. It might not be the most efficient, right? I mean, if you were at 1,000,000 and you wanted to get to 1,000,001, it would probably be really inefficient to grind 1,000,000 down to zero and then go up to 1,000,001. There are better ways, but it would work, right?
Yeah.
Yeah. Okay.
It's reachable.
Yeah.
Is this math like school? Is this math that anyone used in daily life? Is anything other than
What do you think?
tabling ropes? Well, that's one thing you can use for tabling ropes, and
There's probably some
Are
sort of
they
scientific
ropes?
application or something. Well, you work with negatives and positives and fractions all the time, so
Yeah.
even if you're not applying it in this way, you're still going to use your fractions and your knowledge of negatives and positives. And finding out what variables represent and all the information you used to learn this will be used somewhere else. And a lot of exactly these finding out how it all works.
Besides, it's really cool.
Yes. Something one of my teachers once told me is that when they're studying proteins, because proteins get all folded up on one another and bent together.
Yeah.
If you can assign numbers to the way that the proteins are folding, I can help you understand the way that they're getting
so it's
twisted.
sort of like how these ropes are
Mhm.
folded.
Imagine that was inside your
Actually, DNA.
DNA.
If you look up Conway's Tangles on the web, you'll find a whole bunch of references to DNA and RNA tangling. That there are some applications, because they are just two strands, right?
Because twisting this did make it look like the DNA.
Yeah, exactly. And then DNA can, can get tangled in
Tangled
worse ways than
around
the
stuff.
standard
Yeah.
helix in a cell with things bouncing around, especially when it's unwinding for reproduction and stuff. They got loose ends floating around, and they can tangle in funny ways. I think we're
done, yeah.
So I hope you learned something.
Yeah, thank you very much.
Thank you.